Hey everyone, welcome to this amazing new video by Simplilearn. In this video, we are going to discuss the top 20 big data Hadoop interview questions. But before we begin, consider subscribing to our channel and hit the bell icon to never miss any updates from Simplilearn. Big data in layman's terms is a vast volume of high-velocity data. Think of hundreds of gigabytes of data flowing through in minutes. Obviously, this cannot be stored and processed through traditional data processing systems. Now, this is where Hadoop comes in. Hadoop is an open source framework designed to handle big data. It provides a distributed file system, Hadoop Distributed File System or HDFS, and a distributed processing framework, MapReduce, that allows for parallel and scalable processing of large datasets across clusters of nodes. Hadoop's architecture enables fault tolerance and high availability, making it suitable for processing big data. Organizations and enterprises globally are on the outlook for skilled professionals who are able to handle such vast volumes of data, help structure and streamline the processing of this data. The salary of a Hadoop developer can vary based on factors like experience, location, company size, and industry. But on an average, Hadoop developers earn anywhere between $80,000 to $150,000 per year, which can go as high as $250,000 for some experienced roles. It is therefore one of the best times for you to get yourself certified and skilled in big data domain. With companies like Google, Adobe, Intuit Oracle, Accenture, Visa, and many hiring Hadoop developers, you must get yourself enrolled in one of our amazing certification training programs to land yourself your dream job. Let me tell you about this global certification program.
Now let's look at some general Hadoop questions. So what are the different vendor-specific distributions of Hadoop? Now all of you might be aware that Hadoop or Apache Hadoop is the core distribution of Hadoop. And then you have different vendors in the market which have packaged the Apache Hadoop in a cluster management solution which allows everyone to easily deploy, manage, monitor, upgrade your clusters. So here are some vendor specific distributions. We have Cloudera, which is the dominant one in the market. We have Hortonworks, and now you might be aware that Cloudera and Hortonworks have merged. So it has become a bigger entity. You have MapR, you have Microsoft Azure, IBM's InfoSphere, and Amazon Web Services. So these are some popularly known vendor specific distributions. If you would want to know more about the Hadoop distributions, you should basically look into Google and you should check for Hadoop different distributions wiki page. So if I type Hadoop different distributions and then I check for the wiki page, that will take me to the distributions and commercial support page, and this basically says that the sole products that can be called a release of Apache Hadoop come from apache.org. So that's your open source community. And then you have various vendor specific distributions which basically are running in one or the other way Apache Hadoop, but they have packaged it as a solution like an installer so that you can easily set up clusters on set of machines. So have a look at this page and read through about different distributions of Hadoop. Coming back, let's look at our next question. So what are the different Hadoop configuration files? Now, whether you're talking about Apache Hadoop, Cloudera, Hortonworks, MapR, or no matter which other distribution, these config files are the most important and existing in every distribution of Hadoop. So you have Hadoop environment.sh, wherein you will have environment variables such as your Java path, what would be your process ID path, where will your logs get stored, what kind of metrics will be collected, and so on. Your core-site file has the HDFS path. Now this has many other properties like enabling thrash or enabling high availability or discussing or mentioning about your zookeeper. But this is one of the most important file. You have HDFS-site file. Now this file will have other information related to your Hadoop cluster, such as your replication factor, where will name node store its metadata on disk, if a data node is running, where would data node store its data? If a secondary name node is running, where would that store a copy of name node's metadata? And so on. Your mapred-site file is a file which will have properties related to your MapReduce processing. You also have masters and slaves. Now these might be deprecated in a vendor specific distribution, and in fact you would have a yarn-site file which is based on the yarn processing framework which was introduced in Hadoop version 2, and this would have all your resource allocation and resource manager and node manager related properties. Again, if you would want to look at default properties for any one of these, for example, let's say HDFS-site file, I could just go to Google and type in one of the properties. For example, I would say dfs.nameNode.name.directory, and as I know this property belongs to HDFS-site file, and if you search for this, it will take you to the first link which says HDFS default XML. You can click on this and this will show you all the properties which can be given in your HDFS-site file. It also shows you which version you are looking at, and you can always change the version here. So for example, if I would want to look at 2.6.5, I just need to change the version and that should show me the properties. Similarly, you can just give a property which belongs to say core-site file. For example, I would say fs.defaultfs, and that's a property which is in core-site file, and somewhere here you would see core-default.xml, and this will show you all the properties. So similarly, you could search for properties which are related to yarn-site file or MapReduce-site file. So I could say yarn.resource manager, and I could look at one of these properties which will directly take me to yarn default XML, and I can see all the properties which can be given in yarn. And similarly, you could say MapReduce.job.reduces, and I know this property belongs to MapReduce-site file, and this takes you to the default XML. So these are important config files, and no matter which distribution of Hadoop you're working on, you should be knowing about these config files. Whether you work as a Hadoop admin or you work as a Hadoop developer, knowing these config properties would be very important, and that would also showcase your internal knowledge about the configs which drive your Hadoop cluster. Let's look at the next question. So what are the three modes in which Hadoop can run? So you can have Hadoop running in a standalone mode. Now that's your default mode. It would basically use a local file system and a single Java process. So when you say standalone mode, it is as you downloading Hadoop related package on one single machine, but you would not have any process running. That would just be to test Hadoop functionalities. You could have a pseudo distributed mode, which basically means it's a single node Hadoop deployment. Now Hadoop as a framework has many services. So it has a lot of services, and those services would be running irrespective of your distribution, and each service would then have multiple processes. So your pseudo distributed mode is a mode of cluster where you would have all the important processes belonging to one or multiple services running on a single node. If you would want to work on a pseudo distributed mode and using a Cloudera, you can always go to Google and search for Cloudera's Quick Start VM. You can download it by just saying Cloudera Quick Start VM, and you can search for this, and that will allow you to download a Quick Start VM, follow the instructions, and you can have a single node Cloudera cluster running on your virtual machines. For more information, you can refer to the YouTube tutorial where I have explained about how to set up a Quick Start VM. Coming back, you could have finally a production setup or a fully distributed mode, which basically means that your Hadoop framework and its components would be spread across multiple machines. So you would have multiple services such as HDFS, Yarn, Flume, Scoop, Kafka, HBase, Hive, Impala, and for these services there would be one or multiple processes distributed across multiple nodes. So this is normally what is used in production environment. So you could say standalone would be good for testing, pseudo distributed could be good for testing and development, and fully distributed would be mainly for your production setup. Now, what are the differences between regular file system and HDFS? So when you say regular file system, you could be talking about a Linux file system, or you could be talking about a Windows based operating system. So in regular file system, we would have data maintained in a single system. So the single system is where you have all your files and directories. So it is having low fault tolerance, right? So if the machine crashes, your data recovery would be very difficult unless and until you have a backup of that data. That also affects your processing. So if the machine crashes or if the machine fails, then your processing would be blocked. Now, the biggest challenge with regular file system is the seek time, the time taken to read the data. So you might have one single machine with huge amount of disks and huge amount of RAM. But then the time taken to read that data when all the data is stored in one machine would be very high, and that would be with least fault tolerance. If you talk about HDFS, your data is distributed. So HDFS stands for Hadoop Distributed File System. So here your data is distributed and maintained on multiple systems. So it is never one single machine. It is also supporting reliability. So whatever is stored in HDFS, say a file being stored, depending on its size, is split into blocks, and those blocks will be spread across multiple nodes. Not only that, every block which is stored on a node will have its replicas stored on other nodes. Replication factor depends, but this makes HDFS more reliable. In cases of your slave nodes or data nodes crashing, you will rarely have data loss because of auto replication feature. Now, time taken to read the data is comparatively more, as you might have situations where your data is distributed across the nodes, and even if you are doing a parallel read, your data read might take more time because it needs coordination from multiple machines. However, if you are working with huge data which is getting stored, it will still be beneficial in comparison to reading from a single machine. So you should always think about its reliability through auto replication feature, its fault tolerance because of your data getting stored across multiple machines, and its capability to scale. So when you talk about HDFS, we are talking about horizontal scalability or scaling out. When you talk about regular file system, you are talking about vertical scalability, which is scaling up. Now, let's look at some specific HDFS questions. What is this? Why is HDFS fault tolerant? Now, as I just explained in previous slides, your HDFS is fault tolerant as it replicates data on different data nodes. So you have a master node and you have multiple slave nodes or data nodes where actually the data is getting stored. Now, we also have a default block size of 128 MB. That's the minimum since Hadoop version 2. So any file which is up to 128 MB would be using one logical block. And if the file size is bigger than 128 MB, then it will be split into blocks, and those blocks will be stored across multiple machines. Now, since these blocks are stored across multiple machines, it makes it more fault tolerant because even if your machines fail, you would still have a copy of your block existing on some other machine. Now, there are two aspects here. One, we talk about the first rule of replication, which basically means you will never have two identical blocks sitting on the same machine. And the second rule of replication is in terms of rack awareness. So if your machines are placed in racks, as we see in the right image, you will never have all the replicas placed on the same rack, even if they are on different machines. So it has to be fault tolerant and it has to maintain redundancy. So at least one replica will be placed on some other node on some other rack. That's how HDFS is fault tolerant. Now, here let's understand the architecture of HDFS. Now, as I mentioned earlier, you would in a Hadoop cluster, the main service is your HDFS. So for your HDFS service, you would have a name node, which is your master process running on one of the machines, and you would have data nodes, which are your slave machines getting stored across or the processes running across multiple machines. Each one of these processes has an important role to play. When you talk about HDFS, whatever data is written to HDFS, that data is split into blocks depending on its size, and the blocks are randomly distributed across nodes. With auto replication feature, these blocks are also auto replicated across multiple machines, with the first condition that no two identical blocks will sit on the same machine. Now, as soon as the cluster comes up, your data nodes, which are part of the cluster and based on config files, would start sending their heartbeat to the name node. And this would be every 3 seconds. What does name node do with that? Name node will store this information in its RAM. So name node starts building a metadata in its RAM, and that metadata has information of what are the data nodes which are available in the beginning. Now, when a data writing activity starts and the blocks are distributed across data nodes every 10 seconds will also send a block report to name node. So name node is again adding up this information in its RAM, or the metadata in RAM, which earlier had only data node information. Now name node will also have information about what are the files. The files are split in which blocks, the blocks are stored on which machines, and what are the file permissions. Now, while name node is maintaining this metadata in RAM, name node is also maintaining metadata in disk. Now, that is what we see in the red box, which basically has information of whatever information was written to HDFS. So to summarize, your name node has metadata in RAM and metadata in disk. Your data nodes are the machines where your blocks or data is actually getting stored. And then there is an auto replication feature which is always existing unless and until you have disabled it, and your read and write activity is a parallel activity. However, replication is a sequential activity. Now, this is what I mentioned about when you talk about name node, which is the master process hosting metadata in disk and RAM. So when we talk about disk, it basically has a edit log, which is your transaction log, and your FS image, which is your file system image. Right from the time the cluster was started, this metadata in disk was existing, and this gets appended every time read, write, or any other operations happen on HDFS. Metadata in RAM is dynamically built every time the cluster comes up, which basically means that if your cluster is coming up, name node in the initial few seconds or few minutes would be in a safe mode, which basically means it is busy registering the information from data nodes. So name node is one of the most critical processes. If name node is down and if all other processes are running, you will not be able to access the cluster. Name node's metadata in disk is very important for name node to come up and maintain the cluster. Name node's metadata in RAM is basically for all or satisfying all your client requests. Now, when we look at data nodes, as I mentioned, data nodes hold the actual data blocks, and they are sending these block reports every 10 seconds. So the metadata in name node's RAM is constantly getting updated, and metadata in disk is also constantly getting updated based on any kind of write activity happening on the cluster. Now, data node, which is storing the block, will also help in any kind of read activity whenever a client requests. So whenever a client or an application or an API would want to read the data, it would first talk to name node. Name node would look into its metadata on RAM and confirm to the client which machines could be reached to get to that data. That's where your client would try to read the data from HDFS, which is actually getting the data from data nodes. And that's how your read-write requests are satisfied. Now, what are the two types of metadata in name node server holds? As I mentioned earlier, metadata in disk, very important to remember, edit log and FS image. Metadata in RAM, which is information about your data nodes, files being split into blocks residing on data nodes, and file permissions. So I will share a very good link on this, and you can always look for more detailed information about your metadata. So you can search for HDFS metadata directories explained. Now this is from Hortonworks. However, it talks about the metadata in disk, which name node manages, and details about this. So have a look at this link if you are more interested in learning about metadata on disk. Coming back, let's look at the next question. What is the difference between federation and high availability? Now these are the features which were introduced in Hadoop version 2. Both of these features are about horizontal scalability of name node. So prior to version 2, the only possibility was that you could have one single master, which basically means that your cluster could become unavailable if name node would crash. So Hadoop version 2 introduced two new features, federation and high availability. However, high availability is a popular one. So when you talk about federation, it basically means any number of name nodes. So there is no limitation to the number of name nodes. Your name nodes are in a federated cluster, which basically means name nodes still belong to the same cluster, but they are not coordinating with each other. So whenever a write request comes in, one of the name node picks up that request and it guides that request for the blocks to be written on data nodes. But for this, your name node does not have to coordinate with other name node to find out if the block ID which was being assigned was the same one as assigned by other name node. So all of them belong to a federated cluster. They are linked via a cluster ID. So whenever an application or an API is trying to talk to cluster, it is always going via an cluster ID, and one of the name node would pick up the read activity or write activity or processing activity. So all the name nodes are sharing a pool of metadata in which each name node will have its own dedicated pool. And we can remember that by a term called namespace or name service. So this also provides high fault tolerance. Suppose your one name node goes down, it will not affect or make your cluster unavailable. You will still have your cluster reachable because there are other name nodes running and they are available. Now when it comes to heartbeats, all your data nodes are sending their heartbeats to all the name nodes, and all the name nodes are aware of all the data nodes. When you talk about high availability, this is where you would only have two name nodes. So you would have an active and you would have a standby. Now normally in any environment you would see a high availability setup with Zookeeper. So Zookeeper is a centralized coordination service. So when you talk about your active and standby name nodes, election of a name node to be made as active and taking care of an automatic failover is done by your Zookeeper. High availability can be set up without Zookeeper, but that would mean that an admin's intervention would be required to make a name node as active from standby or also to take care of failover. Now at any point of time in high availability, a active name node would be taking care of storing the edits about whatever updates are happening on HDFS, and it is also writing these edits to a shared location. Standby name node is the one which is constantly looking for these latest updates and applying to its metadata, which is actually a copy of whatever your active name node has. So in this way, your standby name node is always in sync with the active name node, and if for any reason active name node fails, your standby name node will take over and become the active. Remember, Zookeeper plays a very important role here. It's a centralized coordination service. One more thing to remember here is that in your high availability, secondary name node will not be allowed. So you would have an active name node and then you will have a standby name node which will be configured on a separate machine, and both of these will be having access to a shared location. Now that shared location could be NFS or it could be a quorum of journal nodes. So for more information, refer to the tutorial where I have explained about HDFS, high availability and federation. Now let's look at some logical question here. So if you have an input file of 350 MB, which is obviously bigger than 128 MB, how many input splits would be created by HDFS? And what would be the size of each input split? So for this, you need to remember that by default, the minimum block size is 128 MB. Now that's customizable. If your environment has more number of larger files written on an average, then obviously you have to go for a bigger block size. If your environment has a lot of files being written, but these files are of smaller size, you could be okay with 128 MB. Remember, in Hadoop, every entity, that is your directory on HDFS, file on HDFS, and a file having multiple blocks, each of these are considered as objects. And for each object, Hadoop's name node's RAM, 150 bytes is utilized. So if your block size is very small, then you would have more number of blocks, which would directly affect the name node's RAM. If you keep a block size very high, that will reduce the number of blocks. But remember, that might affect in processing, because processing also depends on splits. More number of splits, more the parallel processing. So setting of block size has to be done with consideration about your parallelism requirement and your name node's RAM which is available. Now, coming to the question, if you have a file of 350 MB, that would be split into 3 blocks, and here 2 blocks would have 128 MB data, and the third block, although the block size would still be 128, it would have only 94 MB of data. So this would be the split of this particular file. Now let's understand about rack awareness. How does rack awareness work? Or why do we even have racks? So organizations always would want to place their nodes or machines in a systematic way. There can be different approaches. You could have a rack which would have machines running on the master processes, and the intention would be that this particular rack could have higher bandwidth, more cooling, dedicated power supply, top of rack switch, and so on. The second approach could be that you could have one master process running on one machine of every rack, and then you could have other slave processes running. Now, when you talk about your rack awareness, one thing to understand is that if your machines are placed within racks, and we are aware that Hadoop follows auto replication, the rule of replication in a rack aware cluster would be that you would never have all the replicas placed on the same rack. So if we look at this, if we have block A in blue color, you will never have all the 3 blue boxes in the same rack, even if they are on different nodes, because that makes it less fault tolerant. So you would have at least one copy of block which would be stored on a different rack on a different node. Now let's look at this. So basically here we are talking about replicas being placed in such a way. Now somebody could ask a question, can I have my block and its replicas spread across 3 racks? And yes, you can do that, but then in order to make it more redundant, you are increasing your bandwidth requirement. So the better approach would be 2 blocks on the same rack on different machines and 1 copy on a different rack. Now let's proceed. How can you restart name node and all daemons in Hadoop? So if you were working on an Apache Hadoop cluster, then you could be doing a start and stop using Hadoop daemon scripts. So there are these Hadoop daemon scripts which would be used to start and stop your Hadoop. And this is when you talk about your Apache Hadoop. So let's look at one particular file which I would like to show you more information here. And this talks about your different clusters. So let's look into this. And so let's look at the start and stop. And here I have a file. Let's look at this one. And this gives you highlights. So if you talk about Apache Hadoop, this is how the setup would be done. So you would have it download the Hadoop tar file, you would have to untar it, edit the config files, you would have to do formatting, and then start your cluster. And here I have said using scripts. So this is in case of Apache Hadoop, you could be using a start all script that internally triggers start DFS and start yarn. And these scripts, start DFS, internally would run Hadoop daemon multiple times based on your configs to start your different processes. Then your start yarn would run yarn daemon script to start your processing related processes. So this is how it happens in Apache Hadoop. Now in case of Cloudera or Hortonworks, which is basically a vendor specific distribution, you would have say multiple services which would have one or multiple daemons running across the machines. Let's take an example here that you would have machine 1, machine 2 and machine 3 with your processes spread across. However, in case of Cloudera and Hortonworks, these are cluster management solutions. So you would never be involved in running a script individually to start and stop your processes. In fact, in case of Cloudera, you would have a Cloudera SCM server running on one of the machines and then Cloudera SCM agents running on every machine. If you talk about Hortonworks, you would have Ambari server and Ambari agent running. So your agents which are running on every machine are responsible to monitor the processes, send also their heartbeat to the master, that is your server, and your server is the one or a service which basically will give instructions to the agents. So in case of vendor specific distribution, your start and stop of processes is automatically taken care by these underlying services, and these services internally are still running these commands. However, only in Apache Hadoop you have to manually follow these to start and stop. Coming back, we can look into some command related questions. So which command will help you find the status of blocks and file system health? So you can always go for a file system check command. Now that can show you the files for a particular HDFS path. It can show you the blocks, and it can also give you information on status such as under replicated blocks, over replicated blocks, misreplicated blocks, default replication, and so on. So your FSCK file system check utility does not repair if there is any problem with the blocks, but it can give you information of blocks related to the files, on which machines they are stored, if they are replicated as per the replication factor, or if there is any problem with any particular replica. Now, what would happen if you store too many small files in a cluster? And this relates to the block information which I gave some time back. So remember, Hadoop is coded in Java. So here every directory, every file and file related block is considered as an object. And for every object within your Hadoop cluster, name node's RAM gets utilized. So more number of blocks you have, more would be usage of name node's RAM. And if you're storing too many small files, it would not affect your disk. It would directly affect your name node's RAM. That's why in production clusters, admin guys or infrastructure specialists will take care that everyone who is writing data to HDFS follows a quota system, so that you could be controlled in the amount of data you write plus the count of data an individual writes on HDFS. Now, how do you copy data from local system onto HDFS? So you can use a put command or a copy from local, and then given your local path, which is your source, and then your destination, which is your HDFS path. Remember, you can always do a copy from local using a -f option. That's a flag option, and that also helps you in writing the same file or a new file to HDFS. So with your -f, you have a chance of overwriting or rewriting the data which is existing on HDFS. So copy from local or -put, both of them do the same thing, and you can also pass an argument when you're copying to control your replication or other aspects of your file. Now, when do you use DFS admin refresh nodes or RM admin refresh nodes? So as the command says, this is basically to do with refreshing the node information. So your refresh nodes is mainly used when, say, a commissioning or decommissioning of nodes is done. So when a node is added into the cluster, or when a node is removed from the cluster, you are actually informing Hadoop master that this particular node would not be used for storage and would not be used for processing. Now in that case, you would be, once you are done with the process of commissioning or decommissioning, you would be giving these commands, that is refresh nodes and RM admin refresh nodes. So internally, when you talk about commissioning, decommissioning, there are include and exclude files which are updated. And these include and exclude files will have entry of machines which are being added to the cluster or machines which are being removed from the cluster. And while this is being done, the cluster is still running. So you do not have to restart your master process. However, you can just use these refresh commands to take care of your commissioning, decommissioning activities. Now, is there any way to change replication of files on HDFS after they are already written? And the answer is, of course, yes. So if you would want to set a replication factor at a cluster level, and if you have admin access, then you could edit your HDFS-site file, or you could say Hadoop-site file. And that would take care of replication factor being set at a cluster level. However, if you would want to change the replication after the data has been written, you could always use a setrep command. So setrep command is basically to change the replication after the data is written. You could also write the data with a different replication, and for that you could use a -d DFS dot replication and give your replication factor when you are writing data to the cluster. So in Hadoop, you can let your data be replicated as per the property set in the config file. You could write the data with a different replication. You could change the replication after the data is written. So all these options are available. Now, who takes care of replication consistency in a Hadoop cluster? And what do you mean by under, over replicated blocks? Now, as I mentioned, your fsck command can give you information of over or under replicated blocks. Now, in a cluster, it is always and always name node which takes care of replication consistency. So for example, if you have set up a replication of 3, and since we know the first rule of replication, which basically means that you cannot have 2 replicas residing on the same node, it would mean that if your replication is 3, we would need at least 3 data nodes available. Now say for example, you had a cluster with 3 nodes and replication was set to 3. At one point of time, one of your name node crashed. And if that happens, your blocks would be under replicated. That means there was a replication factor set, but now your blocks are not replicated, or there are not enough replicas as per the replication factor set. This is not a problem. Your master process or name node will wait for some time before it will start the replication of data again. So if a data node is not responding, or if a disk has crashed, and if name node does not get information of a replica, name node will wait for some time and then it will start re-replication of those missing blocks from the available nodes. However, while name node is doing it, the blocks are in under replicated situation. Now when you talk about over replicated, this is a situation where name node realizes that there are extra copies of block. Now this might be the case that you had 3 nodes running with a replication of 3. One of the node went down due to a network failure or some other issue. Within few minutes, name node re-replicated the data, and then the failed node is back with its set of blocks. Again, name node is smart enough to understand that this is a over replication situation, and it will delete set of blocks from one of the nodes. It might be the node which has been recently added, it might be your old node which has joined your cluster again, or any node. That depends on the load on a particular node. Now we discussed about Hadoop, we discussed about HDFS. Now we will discuss about MapReduce, which is the programming model, and you can say processing framework. What is distributed cache in MapReduce? Now we know that when we talk about MapReduce, the data which has to be processed might be existing on multiple nodes. So when you would have your MapReduce program running, it would basically read the data from the underlying disks. Now this could be a costly operation if every time the data has to be read from disk. So distributed cache is a mechanism wherein data set or data which is coming from the disk can be cached and available for all worker nodes. Now how will this benefit? So when a MapReduce is running, instead of every time reading the data from disk, it would pick up the data from distributed cache, and this will benefit your MapReduce processing. So distributed cache can be set in your job conf, where you can specify that a file should be picked up from distributed cache. Now let's understand about these roles. So what is a record reader, what is a combiner, what is a partitioner, and what kind of roles do they play in a MapReduce processing paradigm or MapReduce operation. So record reader communicates with the input split, and it basically converts the data into key value pairs. And these key value pairs are the ones which will be worked upon by the mapper. Your combiner is an optional phase. It's like a mini reduce. So combiner does not have its own class. It relies on the reducer class. Basically, your combiner would receive the data from your map tasks which would have completed, works on it based on whatever reducer class mentions, and then passes its output to the reducer phase. Partitioner is basically a phase which decides how many reduced tasks would be used, aggregate or summarize your data. So partitioner is a phase which would decide based on the number of keys, based on the number of map tasks. Your partitioner would decide if one or multiple reduced tasks would be used to take care of processing. So either it could be partitioner which decides on how many reduced tasks would run, or it could be based on the properties which we have set within the cluster, which will take care of the number of reduced tasks which would be used. Always remember, your partitioner decides how outputs from combiner are sent to reducer and to how many reducers. It controls the partitioning of keys of your intermediate map outputs. So map phase, whatever output it generates, is an intermediate output, and that has to be taken by your partitioner or by a combiner and then partitioner to be sent to one or multiple reduced tasks. This is one of the common questions which you might face. Why is MapReduce slower in processing? So we know MapReduce goes for parallel processing. We know we can have multiple map tasks running on multiple nodes at the same time. We also know that multiple reduced tasks could be running. Now, why does then MapReduce become a slower approach? First of all, your MapReduce is a batch oriented operation. Now, MapReduce is very rigid and it strictly uses mapping and reducing phases. So no matter what kind of processing you would want to do, you would have to still provide the mapper function and the reducer function to work on data. Not only this, whenever your map phase completes, the output of your map phase, which is an intermittent output, would be written to HDFS and thereafter underlying disks. And this data would then be shuffled and sorted and picked up for reducing phase. So every time your data being written to HDFS and retrieved from HDFS makes MapReduce a slower approach.
Here we wrap up with top 20 big data Hadoop interview questions. If you like this video, do share it with your friends and stay tuned with Simplilearn for more updates. Thanks for watching this video.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.